I want to introduce our next speaker, who is Douglas Friedman, the CEO of BioMADE. Doug is the CEO of BioMADE. Like I mentioned, he's a leader in advancing the U.S. industrial biomanufacturing ecosystem. Additionally, he serves as a consultant at the White House Office of Science and Technology Policy, focusing on non-health biotechnology policy and national security, with expertise in synthetic biology and industrial biomanufacturing. Douglas is dedicated to sustainable biotechnology and fostering community partnerships. He has extensive experience in academia, industry, and policy advisory roles, including serving on committees such as the Department of Commerce's Bureau of Industry and Security, Materials and Equipment, Technical Advisory Committee. That's a mouthful. Looking ahead, we are excited about the potential for BioMADE to establish its national network of bioindustrial manufacturing pilot facilities in our great state of North Carolina. So please join me in welcoming Douglas.
All good. All right. Thank you for having me. Thank you, Greg, not only for including me here today, but also for including industrial biomanufacturing throughout this Cleantech Summit. I've learned a lot while spending my time here, and I encourage all of you, especially those of you who have had less experience in the industrial biomanufacturing universe, to spend some time at the other sessions. There was a great session just before this one on scale-up challenges, and there's a precision fermentation panel discussion immediately after this. And so plugging these other sessions is very important to me. This buzzes when you click it, which is a little disconcerting. I'm going to start a little bit with my background. So I'm a physical organic chemist by training, which has nothing to do with biology or manufacturing, and yet now I focus on biomanufacturing. And the reason I'm starting here is because we've talked about and focus on decarbonization. And I have a warning. The warning is I'm going to talk a lot about using carbon, which I realize is different than decarbonization and is a different focus from what a lot of the energy discussion has been. But sitting here as a chemist, what I think about primarily is the global chemicals industry. And the global chemicals industry is tied directly into, currently, the petroleum industry and everything that we've been talking about. And chemicals and materials and products that we use throughout the United States and around the world, these are all things that we need to continue to maintain as we approach decarbonization in the energy industry. And so if we are getting our chemicals and materials primarily from the petroleum industry today, what are the solutions? If that is going down, what is going to take its place? And it's an enormous industry, right? I'm focused on the chemicals part of the industry here, right? We're talking about a $1.1 trillion global industry, and that's only the top 50 firms. If you take everyone else, it's $6 trillion. These are enormous industries that we're talking about. And what this ties back to is a question of supply chains. And so I'm going to just walk through an example of how I think about supply chains and how we can then think about using industrial biomanufacturing to solve some supply chain problems as well as other problems I'm going to articulate here. Right? So if you take a paint or a coating or something, it's on an airplane for no particular reason, that is made up of some solvents, resins, pigments, additives. Those come from chemical precursors, some organic chemicals and inorganic chemicals, and typically today those come from petroleum and mining. But they don't actually come from petroleum and mining, right? We're not going back far enough in the supply chain, right? They come from dead dinosaurs, formation of the Earth, the Big Bang. The purpose of this is to say when we think about supply chains, we often think about them only on the surface, right? Only the basics. But in fact, supply chains are complicated networks and ones that we don't do a good job tracking really anywhere, right? And so there was a story in the Washington Post last year in 2023 that, I'm going to skip this. There's a story in the Washington Post in 2023 really focused on a fuel supply chain. It really doesn't matter the product. This is an example for anything. And this story, I like it because it talked about fuel arriving at a naval facility in the Indian Ocean. And it didn't take a lot of work to follow that fuel and say, okay, well, it came from a facility in Greece, okay. Well, the crude oil came from Turkey. Well, the oil came from Russia. And I bring this up to say this was happening during the war in Ukraine, right? When we have sanctions against Russia right now. And this is ongoing because we're not paying enough attention to supply chains. So how do we think about solving the movement of carbon that we need and bringing in new solutions that solve a bevy of problems? And that is really at the crux of it what my organization is focused on doing. So BioMADE is an organization, we are relatively young. We launched almost exactly 3 years ago. We were started as a nonprofit public-private partnership, really a bridge between the federal government and the private sector to catalyze using industrial biomanufacturing to solve national problems. And I'll talk about what that is in a minute. But it's really taking all of the aspects of technology, building them into robust supply chains, thinking about education and workforce and what is to come, and ultimately bringing together a large network and large ecosystem that can solve some of these problems. And so there was a reference earlier about infrastructure. And you can see in our mission statement, de-risking relevant infrastructure is at the core of what we do, and I'm going to talk about that at the end of the talk. But thinking about how we build a sustainable, domestic, end-to-end bioindustrial manufacturing ecosystem to bring from the types of supply chains that we have today to a whole new set of supply chains is what we're all about. And I am fortunate in leading this organization to work with an incredible group of companies, universities, nonprofits, technical colleges, K-12 school districts that all participate in our network. BioMADE today is in 39 states and are doing work with companies as large as Cargill and as small as a 3-person startup that just started working in RTP. We're here in North Carolina. I'm thrilled to be here in North Carolina. We have a robust ecosystem of large and small companies here. One of the things I'm most proud of about BioMADE's work here in North Carolina is really the well, I'm at UNC, so I can make fun of NC State. So just take NC State off of this. And you'll notice that the focus is really on community and technical colleges and some of the core education and workforce development that you're going to need for a long-term manufacturing ecosystem and solutions. And this is a critical part of how we build these networks, and North Carolina has done an incredible job of focusing on that. And so BioMADE works in a variety of program areas. We do work in technology and innovation. I'll give a few examples. We work in education and workforce development, and we build in this idea that if we are not considering safety, security, sustainability, social responsibility in all of this work, then we're not doing it right. Right? It's at the core of what we do, and all of these elements are interconnected. And BioMADE works primarily on a project basis with our members. We have over $170 million of funding deployed across 76 projects, large numbers of members now working across those technology spaces. And so now I'm going to jump back and say, what am I even talking about here? So what is biomanufacturing? What are we even focused on? Well, it's this idea that you can take something other than petroleum. You can actually take petroleum, that's a different talk, but take something other than petroleum, biomass, and go through a pretreatment, conversion process, primarily today through fermentation, and create fuels, products, power, the chemicals and materials that we need using an entirely different supply chain model and supply chain approach than we use today. And really in just the last decade, an incredible number of biomanufactured chemicals and materials have found their way into everyday products. And so just on this slide is a smattering, a random really assortment of products that cover everything from nutrition to health, to beauty and health and personal care, clothing, sports gear, all of which have chemicals or materials that were made through biomanufactured processes. So, okay, we're doing this today. Why is the US good at this? Why should we be even better? Well, it turns out the US is incredibly good at growing agricultural products that can be used for biomanufacturing. Through a combination of hard work and luck, the agricultural ecosystem in the United States is arguably the envy of the world. The diversity of things that we can grow uniquely in the United States is incredible. And we're talking about taking some of the things that we grow and building them into how we do manufacturing of chemicals and materials. I don't have a slide on this, but where are the petroleum refineries that lead to the chemical refineries that lead to the chemical processing that lead to the chemicals that we use today? Well, they're primarily on the coasts, right? Because we import a bunch of oil and then we put them in these things and then well, it turns out we grow things pretty much everywhere. And so starting to think about now how you distribute your biomass and then build in resiliency, right? Administrator Reagan said we don't use climate crisis anymore, so I'm not going to say climate crisis. I'm going to say some of the weather-related challenges associated with climate change that we are facing, right? If it's freezing in Texas and everything is shutting down, you really wish you're doing some manufacturing somewhere else. So how do you distribute these things in a way that can really support a robust ecosystem? And I greatly appreciated Administrator Regan's focus on the positive aspects of this. This is all about creating economic growth, building in resilience, starting to work with communities that have historically not been the beneficiaries of financial support and technology development that has come into biology, right? UNC does great, RTP does great. Rural areas do not generally see benefits from biology-related support. But they can and should and will in industrial biomanufacturing, right? That's what this is about. And as an example, you can start to think about how you build this into the agricultural ecosystem, right? You can think about, through a case study that was done in Iowa, you can already model millions of dollars of price benefit directly to farmers by having alternate sources of customers for their products. And then that gets put on steroids when you start to think about the ancillary jobs, all of the indirect benefit that comes to communities by doing these things. It is inherently built into a circular economy. And again, building in how we think about using biology to manufacture these products. So again, why is this not done yet? Well, today we can biomanufacture, theoretically, we can biomanufacture probably upwards, that's a low estimate, it's probably closer to 500 million metric tons per year of various products. The tools of synthetic biology and underlying biotechnology that the US has really led in for the last 30 years plus have made that possible. There's some faculty here at UNC that have been driving that. But the problem is scale. If we just take plastic production, right? 400 million tons. This includes all possible plastics. Well, bioplastics make up 0.6% of that today. That is a hard challenge to solve. And it's not just technology. Part of it is economics. And so yes, North Carolina has a long history in pharmaceutical biomanufacturing, right? I'm here to talk about industrials, but I'm going to compare to pharma here for a minute. And so let's just compare an mRNA vaccine and mRNA manufacturing with 1,4-butanediol. And there's a real expert on 1,4-butanediol here in the room. I challenge you to find this person. The question is, does your product go in a small vial or does it go in a tanker? Well, let's look at the economics of it and let's look at the manufacturing of it. So on the left, right, you see your tons per year of manufacturing. mRNA, I'm surprised you can even see it down there in how much you actually need. And I loved asking a team member to do this calculation. roughly $11.5 million per pound. That is the selling price of mRNA. Dollars on the pound, and we use a ton of it. The margin here is astronomically different. The business challenge is astronomically different, and the technology challenge and then the technology for manufacturing becomes critically important. It's the make or break between having a product that can actually compete on the market or not. And I haven't even talked about price on carbon. I haven't talked about subsidies. I haven't talked about any, just the straight, simple economics tell you how hard of a problem we have. And so I'm going to go through a few examples now, and I'm just going to go very quickly at a high level, because my goal here is to get you to understand the full scope of what's there, to then dig into areas that are of interest, because the ability here is so massive. Technology and innovation. So I talked about, right, BioMADE has technology and innovation related programs, and I want to give you a few examples of the types of things we do. BioMADE, again, we're a nonprofit partnership and a bridge. We are not a chemical manufacturer, and we are not a technology developer. That big slide of a zillion logos, that's who do that work. But we have an opportunity then to work with them in a coordinated fashion to build underlying technologies and start to experiment in ways that can get you to scales that matter and start to have an impact on the relevant communities that we're focused on. And so this project is one by a company called Microbiome. Microbiome is based in California, and they are essentially working to manufacture acrylic acid. Acrylic acid is a monomer that goes into a wide variety of products, including diapers, which is a big one. Instead of using petroleum, they're using dairy whey. So they're using a waste product from dairy production in collaboration with a farm about 80 miles away. Well, so if I am not an expert in dairy production, but I have come to learn that one of the challenges farmers face in dairy production is acidic waste that has to get removed from their farms, right? So farmers pay to have this waste removed. Well, this project and this company is focused on taking something that is a coster for farmers to get removed and to now pay them and use it as a feedstock to manufacture a chemical that we use in everyday products. Completely bypassing the petroleum economy, completely bypassing essentially all of the supply chains that we know are problematic today. Another example, and this is related to scaling technologies, is I pointed out, right, we're talking about metric tons of production, so we need to be thinking big. Getting from a laboratory, say laboratory work that might be done at UNC or in a university or in a small company, to a, in this case, 625,000 liter reactor is a very hard task. There are a number of companies represented here, here at this conference that are trying to do this type of thing right now for products. Ask them how hard it is. It is a hard task. Well, if we were better able to do that predictably, then we'd bring down the cost of getting to manufacturing scale. And so a team with Checkerspot and UC Davis, University of California, Davis, are working on a project to do just that. Company Industrial Microbes. In this case, taking ethanol and CO2 as a feedstock to convert to plastics, fibers, and they're also working on acrylic acid. Now we're talking about a whole different way of thinking about CO2 utilization for product formation. We should always remember, right, so I'm a chemist, I'm not the bio guy. Part of the reason I got into this is I realized that biology is always going to be better at chemistry than I am going to be. They literally take CO2 out of the air and make incredible things, and evolution has brought us to do that with exquisite control. We're able to control that a little bit right now, and that can be transformative in making products using these types of technologies. I think one of the students that was up here before with Deputy Secretary Turk was focused on data, so we threw in a data example, right? Bringing machine learning and analytics to the table, right? There's students at the University of Illinois right now trying to optimize processes in a way that's going to help move this industry forward. And these are just 4 examples, right? I've got 76 more for the long version of this talk. But this isn't the only problem. You know, I mentioned before that commercialization and the business aspects of this are just as important as the technology aspects of this. And so we think about, and especially for me personally, coming from a scientific background, we think about the technology readiness levels and the technical risk, but we have to build in the business risk and understanding the wide array of business conditions and business risks that are associated with this, because if we don't get to commercial scale and we don't see manufacturing done in the United States, then we're not successful in our broader mission. And there are a few examples of this. Techno-economic analysis came up before, so starting to build in and understanding what is the interplay between technology development and the economics of your product. How can you do this more predictably? Companies focus on and do this every day. This is something that I strongly encourage students that are working to get into this space, spend some real time on. You will become the favorite candidate for all of the jobs that you will eventually apply for if you can talk about and perform techno-economic analysis. I brought up the workforce before. Right? UNC is certainly training incredible scientists and engineers that are going to enter the workforce. But as a general rule, a UNC-trained scientist is not going to be the manufacturing technician in a manufacturing production facility. It's not that it can't be done, it's not as likely to be done. So how do we build in the full scope of workforce training so that companies have people to hire when we're successful at this? I already talked about building in the safety and security and social responsibility and sustainability into this. One of the reasons I got into this in the first place is that the industry already cared about this before I started working in this space. It's cared about it for decades. And there's a real inherent interest in building this into the work that we do. And ultimately, when you start to layer on agriculture, you start to layer on all of the opportunities that the U.S. has to bring to the table and consider distributed biomanufacturing, you get to something that can bring you to equitable development across the country. And one of the things BioMADE is focused on today is expanding the scope and the infrastructure that is available to companies to build out biomanufacturing facilities. And so one of the challenges that companies in the US face today is scaling technologies requires access to some infrastructure that for the most part is not available today. We're talking about some infrastructure that looks a little bit like a craft brewery with a whole lot of complicated downstream processing and purification equipment that companies need access to, but companies need access to for a few weeks, a few months, maybe a few runs. They don't need to build them themselves. And the US has not done a great job coming out of the underlying biotech and biomanufacturing to get to help bridge to full commercial scale. And so this is something BioMADE has been very focused on, establishing infrastructure at relevant scale and what we're trying, that companies will need. And so a couple of years, I guess a year and a half ago, we announced a plan to establish a network of pilot and intermediate scale infrastructure in the United States. We've spent a lot of time and effort working to get Congress on board, to get the administration on board, to get state and local communities on board. Companies were already way on board. And fortunately, we were successful in convincing Congress to pass some relevant legislation to authorize this program and allocate in FY23, fiscal year 23, $300 million to kickstart this effort. I'm also very pleased to say I learned this morning that in the current funding bills that are slated to be passed by this weekend, an additional $100 million will be added to this, which is incredible. And so we're moving. We announced last year that we're going to establish our first facility and campus in Minnesota. The state of Minnesota has allocated a pool of state funds up to $100 million to enable that. And just last week, we announced a down select to 6 additional states that we want to partner with closely to understand what is the state and local community's plan for this. We view ourselves at BioMADE as facilitating a national movement. It is not our place to come to North Carolina and say, this is what makes sense in North Carolina for industrial biomanufacturing. That's what we need you for. That's what we need companies here to bring up. This is what we need partnership with the state to understand what are the opportunities and how can we bring some of the success we've had at the federal level down to the local level and build partnerships that can last 20, 30, 50 years and result in production biomanufacturing in each of the states we're in and ultimately in every state in the country. So that as the work that's going on to enable the clean energy transition on the energy side is happening, we are also focused on transitioning the chemical and material production so that we don't, great problem to have, one of us gets ahead of each other. If one of us gets ahead of each other and we're not ready, there are real downstream consequences and problems that come from supply chains that we rely on that haven't been solidified. And so that's why we are so focused on this work and grateful to be integrated into a meeting like this to further cement partnerships between the clean tech movements and the industrial biomanufacturing movements that we think really are wholly aligned. And so I will say, when you think about bio, think big. It's not the little squishy thing. We are talking about large-scale efforts here, and I encourage you to further integrate into these efforts and really look forward to continued dialogue with colleagues here in North Carolina about how the state can further integrate into these efforts. Thank you so much.